I could never. No, your body hurts. So, I would never be able to that.
A relation is a set of ordered pairs. Sometimes you can list every ordered pair in a relation, sometimes you can't. But a relation is a set of ordered pairs. A function is a relation for which each distinct value of the first component in the ordered pair, there is exactly one value of the second component. Decide whether each relation defines a function. Look at relation F. 1, 2, -2, 4, 3, 4. Is relation F a function?
Yeah.
It is a function. Why?
Because the X is doesn't repeat.
The X doesn't repeat.
Every X that's there has one Y value that goes with it. F is a function. Relation G.
What?
Same.
Relation G. Is it a function?
No,
Not a function. Why?
the X is repeat.
This X value of 1 maps to that one. This X value of 1 maps to 2. This value of X equals 1 maps to 3. This is not a function. Relation H. Is it a function?
No.
Not a function. Why not?
X is
The X is repeat.
Okay. -2 goes to 1, and -2 goes to 0. Domain and range. For every relation consisting of a set of ordered pairs x, y, there are two important sets of elements. The set of all values of the independent variable x is the domain, and all the y value dependent variables is the range. Anything new there?
No.
Nothing new? All right. Give the domain and range of each relation. Tell whether the relation defines a function. What is the domain of relation A?
3, 4, 6.
3, 4, 6. In order from smallest to largest, and does not repeat. Even though in the relation itself, the x value of 4 does repeat, we do not repeat it when we're defining the domain. The range of relation A.
-1, 2, 5, and 8.
-1, 2, 5, and 8. In order from smallest to largest, nothing repeats. Is relation A a function?
No.
Not a function. Because of those two guys. Relation B. Domain is
3, 4, 6, 7, -3. -3, 4, 6, 7.
-3, 4, 6, 7.
The range is 100, 200, 300.
Range is 100, 200, 300. Is it a function?
Yes.
relation C, domain.
-5, 0.
Range,
2.
function or not a function?
Function.
Easy stuff,
What? Not a function?
is a function.
Oh, yeah, I can't tell.
Letter A, what's the domain?
-1, 0, 1, 8.
Range,
-3, -1, 1, 2. Yeah, you saw that, Diego? I took the answer out of your mouth. A function. Oh wait, never mind, doesn't ask. Just making
You
sure.
go right here.
Ahead of the game.
No, I'm just so good at this.
You're like 2 slides ahead.
Not function.
Okay, how about the domain of B?
-4 and 4.
Okay, so what do you want to do?
X is -4 and 4.
X is greater than or equal to negative.
No, -4 is the first one. That's the
Okay.
first thing you put.
Okay, -4.
Greater than or equal to?
That better not
Less, okay, so less than or equal to.
be. Okay,
That's
X.
X.
okay.
And then less than or equal to 4.
So,
Oh.
so this is set notation here, okay? We're talking about the set of numbers from -4 to +4. This is a compound inequality. Compound inequalities only use less than symbols.
Really?
If I ever see a greater than symbol in a system like this, it's wrong. It's always less than. Now, can it be -4?
Yes.
Yes. Can it be +4?
Yes.
Yes, that's why the equal sign. Someone said something about interval notation. I think it was Leilani.
Yeah.
Okay, we can write this in interval notation. So this is set notation. We can also do it in interval notation.
Oh wait, let me see if I can. Yeah, you gotta do a bracket
Why?
because it's equal to.
Okay, because a bracket has a built-in equal sign, right? A bracket has an equal sign and then it's got a bar on the side. Okay, so can it equal -4?
Yes.
Yeah, so it's a bracket.
And then 4.
Can it equal 4?
Yes.
So we have an equal sign on the 4,
Mhm.
and then we draw a line to make it a bracket.
And that's it.
Okay, so both of these are the same answer.
I'm gonna write that one.
Which one do you use? Well, it depends on what they ask.
Oh.
If you're working a problem on the test or on your homework and it says, write your answer in interval notation, it's gonna be like the second one. Okay? Talk to me about the range.
-6 less than or equal to y less than or equal to 6. Boom.
And you said it would always be less than, right?
Always.
And then you can write that the same as the one above it.
C.
All real numbers.
Okay, the domain is all real numbers.
So is there one?
What? Oh yeah. All of it is all.
Remember, I sometimes wrote that as X is an element of the set of numbers containing the reals. Remember that?
Yeah.
Oh, that was hard.
I would
X
just
is an
put-
element of the real numbers.
X is.
We could also write this in interval notation. If it's all real numbers, how far that way does it go?
Infinity.
Infinity.
Negative infinity.
Negative infinity?
There you
Negative.
Bracket or parenthesis?
go. Parentheses.
Bracket.
Parentheses.
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 Bracket means equals. Can you tell me exactly where negative infinity is?
That's a long one.
Okay? And it goes up to,
Infinity.
with a parenthesis. Infinity always uses parentheses in interval notation.
Why, isn't it, but, oh, because it continues.
Okay? Range?
Oh, It only does a bracket when it's like
numbers.
negative infinity, comma, a number, right?
Yes, and we'll see that in just a little while. I'm not gonna write it both ways every time, guys,
You're good.
okay? And you can write that as negative infinity or infinity as well. Let's go to D.
Domain is all the numbers.
Okay, the domain in this is
All the numbers.
X is an element of the reals, good.
And the range would be
Y is greater than or equal to -3.
Perfect.
That's all.
That's all.
Yeah.
Oh,
Isn't that what's happening?
Oh yeah, 'cause
It started here and it got bigger.
Yeah.
When you said letter first, I was so confused. Like,
Yeah, it's
what
confused.
letter?
Now, we can write that in interval notation.
Y'all.
Root?
Where does it start?
Bracket -3.
Bracket, it starts at -3 and goes to,
Comma,
Comma,
infinity.
infinity, parentheses.
Oh,
Okay.
see, there you go. That's what I said earlier.
Wait, where's the